everyone. Welcome to Proficy 2025, our annual leadership strategy and product launch webinar series. My name is Alexis Murphy, and I'll be your host today. On today's webinar, we'll be exploring the transformative potential of the CIMPLICITY Tracker add-on. Designed to streamline the tracking, routing, and sequencing of discrete part manufacturing processes, CIMPLICITY Tracker empowers manufacturers to optimize operations, reduce downtime, automate routing, and enhance product quality. CIMPLICITY Tracker can help your company maintain a competitive edge by ensuring seamless integration and real-time visibility across your production line. Whether you're looking to improve assembly line efficiency or enhance product traceability, this webinar will provide valuable insights and practical strategies to elevate your manufacturing processes. Before we get into today's presentation, I want to be sure to mention that today's event may include forward-looking statements. The information presented is intended to be an outline of general product direction, and it should not be relied on in making a purchasing decision. Now for some quick housekeeping. You should all see an interface with some buttons at the bottom of your screen. They look like the ones on the right side of the slide here. Please send any questions you have through the orange chat bubble button. Through the purple envelope button, you can contact our team. The blue paperclip button is our most important, as it's where you'll find relevant content and resources related to today's webinar. Through the orange person icon, you can connect with today's presenter and product manager, Chad Smith. If you need any technical assistance, please reach out through the orange question mark button, though most issues can just be resolved by refreshing your browser. And lastly, please share your feedback. We have that pink checklist button there where you can send us your different challenges, different initiatives. It's really how we build our products collaboratively with your insight. So please send any information you have through that. Now I'd like to introduce today's speaker, Chad Smith. He is a product manager for CIMPLICITY. Chad has over 25 years of experience in industrial software. He has held roles in quality assurance, software development, engineering leadership, and technical product management, contributing across the full life cycle of HMI SCADA and routing and sequencing solutions. He holds a degree in computer engineering from the University of Alberta, and he lives on acreage near Kalmar, Alberta, where he enjoys taking on never-ending projects, playing pickleball and table tennis, and spending time with his 6 kids and growing number of grandkids. So with that, I will pass it over to Chad to take us through today's presentation. Take it away, Chad.
Hello, everyone. Welcome to our presentation today. I'm excited to be with you and talk about our Proficy CIMPLICITY Tracker module. Tracker is built on our CIMPLICITY's proven HMI SCADA platform. Tracker has been used in production facilities for years with proven results and value. Tracker is a powerful and valuable add-on to our Proficy CIMPLICITY HMI SCADA and Proficy portfolio offering. It provides comprehensive real-time routing, sequencing, tracking, and order execution management capabilities to discrete manufacturing customers built on top of our proven HMI SCADA. Tracker differentiates itself from traditional MES systems because of its close coupling with our SCADA system to support tracking and decision-making in real time. Tracker is ideal for high volume, high variability, and high value operations. CIMPLICITY Tracker is extensively used by many well-known and large manufacturers. While Tracker is well-suited and extensively used in automotive manufacturing, it is also used by customers in other discrete manufacturing plants, such as appliances, computer assembly, and even robotic parking facilities. Vernova's Proficy software suite is a fully integrated manufacturing management platform, stretching from the control system layer all the way up to the MES and IT system layers. Tracker is a valuable addition to the Proficy portfolio capabilities and integrates with the portfolio, allowing you to digitally transform your plant from the shop floor to the top floor. We're excited to introduce you to and demonstrate some of the key capabilities Tracker offers for you to consider to help you solve your manufacturing challenges. With that, I'll now turn it over to my colleague, Nick Miller, who will highlight some of the key capabilities and features our tracker module offers.
Okay, so first I just wanted to go over about some of the things that make up Tracker. Tracker is composed of several services and data models really designed for the manufacturing industry, and they are closely coupled with Proficy, CIMPLICITY, and the entire suite. It all starts with the production process. You take any production process or facility, you look at the areas, the regions, what routes your materials and products can move between those regions, and those types of items, such as the products that you're building on the floor, or material inventory that you've got in storage, your carriers, your equipment, or anything that you're really wanting to keep data about. Tracker updates information about the models at runtime by connecting to your control system through points. This helps to trigger movement and region transition of an item and detailed attributes about the item in production, such as what is the paint color, or is it a 2-door or 4-door vehicle, or any data collected from a PLC during a production phase. Tracker also includes services for automated decision support, a runtime scripting engine that we call RCO. It allows for custom scripting, but also includes dozens of function blocks widely used in manufacturing. This provides a configurable set of rules designed to achieve key manufacturing outcomes. Perhaps you want to do color blocking at the paint shop. Perhaps you have a product ratio balancing that you're trying to achieve, or you're simply trying to achieve a certain build sequence based on first in, first out. RCO is very flexible and scalable, allowing you to have multiple logic and output modules to be stored along with complex trigger sequences. These are tied to standard output points, so you can always view the execution status of this decision support system in real time. Along with that, we have Tracker order execution management functionality and function blocks. This makes it easier to track and trace what orders have been put into the system versus what actual product has been produced, whether it's post-production, in production, or in pre-production, planning perhaps for the next shift or the next day's production activities. Tracker also comes with extensive logging and traceability. These are built both with API access and standard SQL database access. It can give you a real-time plus a drill down and view into perhaps a quality issue that's identified at a station. And perhaps you need to identify all the products that recently passed through that station and to do a reinspection. Tracker services output a lot of standard information, such as how many items there are in an area or region, and it does this through points. But it also provides services that can provide calculated or item key information, data as points as well. Perhaps you want to show the quantity of items in an area broken down by a different type or attribute, such as color or the model of the vehicle, whether they're 2 doors or 4 doors, and see how many of each exist in the region. You can use these points to build your SimView HMI displays with as much detail and drill down capabilities as you need. As we go forward through the slide deck, we'll touch on each of these capabilities one at a time, and then go over how you bring those together to bring a full-fledged application to your factory floor, to your plant manager. And then we'll go into a little demo of these capabilities in real time. So to walk you through each of these tracker services, we start with the tracker models. These are models for production facility based on regions. That's kind of where we start. These may be a sequential region like a conveyor system, or a pooled region as in a material storage area, or some kind of shifting region. The things such as the product on the line, the raw materials, subassemblies, and equipment we model as items, and they occupy a location in a region. And just like in a real manufacturing facility, we have routes defined, and we couple those with triggers from the control system to detect movement of items transitioning from one region to another. The triggers may be as simple as a limit switch. It could be an RFID tag or even a manual or automatic barcode scanner. Uh, we use these inputs to ensure the region model reflects what's actually going on your factory floor in real time. Coupled with the graphic display points, you can build real-time, detailed, summarized views that you can drill into and you can manually control. You can identify bottlenecks and manage the facility day to day. So that starts the production tracking and monitoring. With the next slide, we'll go into talk a little bit about what we call route management or decision support. A lot of decisions need to be made when you're running your plant or factory. Depending on how your process is laid out and modeled with tracker regions, its routes, and its items, there are going to be points in that process where you need to make a decision. What order should flow next, right? Or do I need to pull a late order ahead? Can I block items together with similar attributes to optimize the process and reduce costs? Oftentimes, these decisions especially have common questions and answers, and they can be defined as routine, things that you can find ways to automate. Tracker RCO includes dozens of existing function blocks that look at a history of these questions to support a configurable rule set for those automated decisions. It also allows you, and we encourage you to also be able to build your own function blocks that might be custom for your needs or your facility. You're looking at simple, or complex decisions like, should we simply route this product to the left conveyor or the right conveyor to ensure color blocking? What blank auto body should be selected to move into the next general assembly based on model attributes or order delivery dates? How can I space out production on two different production types on the same line to achieve an optimized ratio? Very simple idea might be if you've got one station that installs windshield wiper blades. Some cars have two, some cars have three with one on the back. You might want to space those out so that the one person who's in charge of putting on wiper blades doesn't get overwhelmed by too many threes in a row. Here we talk about building your application. This is where, in the end, you build upon your model, what we're tracking, coupled with your control systems, and we can build out a manageable application for you to achieve sequence management. The outcomes for the operator and plant manager results in displays that let you parameterize, adjust your production goals, and then view the outcomes in real-time displays, and always stay on top of things. This example shows perhaps ratios of how we're going to feed the line and how we want to set targets and balance. The screen on the right there shows actually how we're pulling off of the feeder lines and sending into the main production line. With that, we have additional tracker services, some of which we'll touch upon in the demos, but we do want to highlight here. While our production tracking and decision support and graphics displays make up the vast majority of it, there's a lot of additional features that we include, such as hold management. These are some additional tracker services and capability that allow you to put a hold on a product or an item. They're very flexible. These hold management capabilities allow you to hold a product or an item, whether it be a specific item or similar items based on their attributes. You can specify holds for any reason, such as a quality issue, perhaps a part a shortage, a supplier delay, or a transportation delay, anything that might impact you where you say, hey, these items need to be held. I'm going to hold them. And you can use it to prevent the movement of items in advancing forward in the production process. And it can also be used to set an alert. These can also be set to expire or reevaluate and recalculate if the conditions change, for example, of the item, or if the delivery comes in. I also wanted to touch on a capability we call broadcast management. Broadcast management is a set of services that allow you to, within a function and a trigger, be able to collect a lot of data about a particular item or about your process, and then disperse that data. One of the most common usages is to print some kind of build manifest or documentation for the product. We do include a form builder we call what you see is what you get. And basically you can lay out how you want this printed and tie that to points, attributes of your items, or any other data available in the tracker system. In real time, this can be focused on a single item and produce a printed output. As I said, the broadcast management is really a way to gather all this data at one time and in one place, and then output it in various ways. The forms printing to outputs as printers is one example, but it can also be used to direct the output to a PLC or as a message to suppliers through either an FTP or HTTP type of connection. They're very dynamic. They dynamically, at real time, gather the properties and attributes that you want to have broadcast, and then you can specify certain locations similar to those decision points using RCOs to gather and disperse that information across your network or typically to a printer. Just kind of summarizing here, some of the example use cases, of course, are in automotive manufacturing, streamlining the assembly line, your high-speed assemblies, whether it be appliances, computer manufacturing, managing complex product assemblies when you need to have specific attributes, perhaps in a build-to-order system where each order is unique and might call for a specific configuration. And the lean manufacturing, trying to optimize and your costs, get a first time right production out there. Lastly, the key tracker outcomes is optimizing your production process, creating a lot of visibility, troubleshooting for the plant manager and his team. We streamline the tracking, routing, and sequencing and operations, reducing downtime and automating those operations. I'm sure you're probably pretty bored with the slide deck and high-level presentation here. So why don't we get right into it, Blaze? He's going to take you live on a simulated plant floor and give you a demo of some of these capabilities. Go ahead, Blaze.
Hi there. This is Blaze Hartley. I'm an engineer with GE Vernova, and I'm going to take us on a walk through the way Tracker actually gets used in practice. So what you see on the screen in front of you is a simulated system, obviously. It does tell us a few things about the kind of stuff you can do with Tracker, though. For example, you'll notice that we've got these regions all over that are supposed to represent physical locations on the plant floor, as Nick was talking about. However, up at the top here, we also have a set of regions that aren't connected to the plant floor, and they actually represent the orders that are in process. And we can look at these orders on the fly at runtime, and we can link them to bodies that are actually, or items that are actually moving through our production process. So as you see things move, when we do a little bit of animation later, you're actually going to see things moving from these order locations through the plant as well as through the actual production process that we're showing you. And what we're looking at is a simulation of an automotive floor. We're looking at the basic body shop, and we're looking at the surface preparation areas, color booths for painting, quality buy-off for repairs and quality assurance, and then a mix bank, which represents an output buffer. So we're going to walk through all of those real quick so you get a little closer look. Now, each of these are going to represent, generally speaking, physical paths down the plant floor. And that's important to remember because each of these paths is represented by physical data points that we can read directly from PLCs. So the tracking goes on without human intervention or coding. The configuration alone drives the whole system. So for example, if we look at this region here, we've got 10 items in the region and 26 over here. If I trigger a decision point, we'll start moving them. And all that is taking data directly from communications and sending it through the tracking system. So in order, we're going to come and we're going to do our ELPO process, which is the basic surface preparation. And this is sealing and paint preparation. And as you see, we're going to see these little control dots here. Each of these represents a decision point within the plant. And each of these has an autonomous agent that's watching it, and that's called an RCO. And we're going to discuss those in detail in a minute as well. As we move through, we're going to come to the paint booths, the color shop, and we're going to see as items move through, we can track them on a screen for users. We can also keep them informational for control centers, and we can use these animations to drive work at stations or to drive your and-on boards. Any of this data can be output directly to a data point, so it can go directly to an and-on board, a PLC, some sort of user screen, anywhere we want to direct it. And then finally, when we get to the end, we're going to come to our quality assurance area, obviously, which has its own repair path built in. So it'll actually be able to cycle bodies back. And then finally, the paint back we discussed, which is simply the output buffer that allows us to send bodies on to the next job. And there will go into a great detail later the running logic that allows us to do all this. And at the very end, we have a broadcast functionality similar to what Nick was showing you, where we can directly output data to printers and put it out on the plant floor so that humans can use it, or it can be set on production or used to drive optical systems, whatever you need it to do. Now, let's go back to the top here. Bear with me for a moment. All right, so if we're looking at the very start here, the first thing we want to talk about is how this gets driven. So if we look here, if we open this up, we'll see that we've got a set of regions that contain data. And this data represents physical production on the plant floor. And the first thing we'll notice is we've actually got two pieces of production for each. This is whereby the system whereby the product will allow you to link multiple pieces of production. And when you track them through your plant, you can track them either by one or the other, or if there are three or four, you can track by any of them, and they've become physically associated. So, for example, in the case of a carrier or a pallet where production sits on it, we can show a single location of production, but have multiple items, each of which represents a piece of production. And each of those items can carry its own genealogy, as Nick was talking about, its own information. You can see this particular body is actually linked to the order that it came from. So there's more detailed information available through that order that doesn't have to be carried on the record through the plant, but we can still access it anywhere we are just by looking through the system or using the API or using the animations. Now, as we move through the plant, we're going to start seeing places where there's actually decisions that need to be made. So right here, we have a split, and we have a decision maker that if I trigger by hand, you can see it decrements this number and increments one of these. And here's the strength of the system. So this RCO is a logic system that's based on filter logic. There are sets of blocks that you can pick off a list. And in this case, those blocks are an attribute matching system, whereby you can decide what is going to go left or right based on the capabilities. So we can see these values here are the capabilities for seal booth 1, and these down below are the capabilities for seal booth 2. Now, these are simply simplicity points. They can be changed on the fly. They are completely dynamic to the production process. So a plant manager or a line boss can come down and change the display dynamically as we go. And if he simply takes out one of these so that it can no longer route black, suddenly we won't have any black left in the new entries to the system. And that dynamicism flows through everything we do. Now, just to get off this a little bit and into how this happens, we're going to have a quick look at what that configuration looks like. Now, those physical locations on the floor are represented here as simple regions. Each of them has a few pieces of information about it. We're not going to go into all the details, but one of those things is it outputs all of its statuses directly to simplicity points on the fly with no need for any user interaction or customization in code or anything like that. And these can be used to drive and-on boards or quality information, whatever you need it to be. That all comes out of the system automatically. And how we drive moving things through the system is what's called a route. And a route simply has a source, a destination, and a point that will drive it. The transition type tells us what it's going to do with the point. In this case, item ID means we have a unique identifier. So we're going to take that unique identifier and move it from our 60 region to our 71 region. And that's pretty much how the entire plant is built, that one little section. When we get to the actual routing that we were looking at, where I believe we're looking at CSO4A. If we look at CSO4A, we'll see that we have a set of information about it. We have triggers, we have decisions, and we have routing logic. The trigger is what starts the decision making. In this case, this button does it for us. The decisions are the two paths it can follow, the D1 or D2. And the routing logic is how we make a decision to do that. When we look at the routing logic, we can see that the blocks that generate it don't require us to do any coding. They simply require us to pick some configuration parameters. And those will drive the plant for us. Now, here's our process capability, and we'll see that it's literally looking for capability point 2, which is simply a simplicity array point that's set on the plant floor. And it tells it what color to do that capability check against. And that's it. With those two blocks that you can configure in moments, you can build logic that simultaneously will run the plant and also gives you dynamic control over the control parameters for that system. And each of these runs independent of all the others. Unless you specifically link them, they will simply look at their own process parameters and make decisions as they go. All right, now next up, we're going to move to the main color, as we saw before. And this would represent our paint booths in a car plant. And we can see as bodies go in here, they are simply being run by the same kind of RCOs that we showed earlier. I'll go into this particular one because it actually has some useful information. And we're looking at number 6A. Now, if we look at our routing logic, we'll see that we've got something in here called the select next highest order decision. And this basically says, if you can't make a decision, just pick the next one. The whole system is designed with fail-safes like this, so that when your system is moving, you can never end up starving or flooding your process unless you intend to do it. The big point here being, of course, that we don't have to use any code to do any of this. And the rules, just like we saw in the capabilities earlier, can live in dynamically configurable settings throughout the plant. And you can define all of these user interfaces custom, or you can do it manually from the built-in user interfaces. And these are the RCO runtime user interface for the control agents. And this is the PRT runtime interface for the tracking system. So you can use those if you're a high-level user, or you can build screens around the graphics that Simplicity gives you the option of using. You can basically configure it any way you want. All this data can output straight to your Andon or your quality system without any intervening systems. It's all whatever you decide. And we get to repair. Nick spoke earlier about holds and how we can use holds to stop production. And of course, one of the main things on a hold is maybe we need to send things back for rework. And we can use our system. Oops, excuse me, I clicked the wrong thing. We can use our system to send bodies into our checking lines so that we can do work against them. And we can look at individual items that have been animated for data input and data reading. And we can use all this on the fly from the floor, or we can do it in a CCR, wherever it needs to be. And then finally, we've got our paint bank. This is the output from our system. This is where we, store our painted bodies and allow them to be output to the rest of the world. The tracking systems make decisions based on what they see. We can look at the individual pieces, and this is custom configured, but it can be configured any way you like with all the data that we're looking at. You can look at these on the fly, and your plant managers or line managers can use them to, again, dynamically change your sequencing rules for output to your next shot. And you can change all the parameters of that rule, including breakability, which allows you to decide whether or not you should execute a rule if it's going to leave you with no options whatsoever. Because sometimes that's something you want, and sometimes that's something that's going to starve your plant. So you make your own decisions on the fly as needed. And as we run things through the plant, the system will send it out to our broadcast system, as we showed earlier. And as we see here, we've got a printable tag for output to our broadcast system. It has barcodes on it. It has data that comes directly from the body that's currently sitting in this location. It's got a bunch of sub information based on other information from the order that it's attached to. All of that is dynamically generated from this design and will then be printed out to the plant floor when it hits the appropriate point in the process. And that's the basics. As I was saying earlier, we've got a series of order systems that we track things through. And these are orders as they go through the system. Each order references something in a higher system, usually an MES or SAP type system. That data, as we showed earlier, will represent all the build parameters for a body or some subset, and can be linked to an order or to the live item on the plant floor, so that both that item on the plant floor can be seen from the order, and the order can be seen from that item on the plant floor. And as we track everything through the system, we use this data to drive all the displays and decision making that you've seen thus far in the demo. And that is all we have for you today.